think about what a container is. Container in real life is an isolated environment. Just think about the meaning of this word. What does a container mean? A container just means an isolated environment. It just means that I need to keep some sugar and some salt. I'll keep them in different containers. I'll keep them in their different isolated environments. So what are containers in IT? They're quite similar to that as well. And we will get to that, right? Before we get into this concept, I'll introduce this concept using a very simple practical example, right? Now, pay attention. So now, it's really important here. If you have two applications, right? Let's say if you have an application A and application B, and both of these applications are totally incompatible with each other. That means application A, if it is on the system, application B would not work. If application B is on the system, A would not work, and they're absolutely not going to work together in the same environment, right? So how would you run them in the environment? How would you run them on a single machine? A simple answer would be you can't, because they are absolutely incompatible, right? So this is a really important thing here, right? They are absolutely incompatible. That means that they are not going to run together. That means that they are not going to run in the same environment, right? So how would I run application A and application B, both of them on a single machine or on the single physical machine, right? Or anything, right? Most of you would say, yeah, you cannot. So what would be a solution to that? Let's have two machines. Let's run application A on machine 1 and let's run application B on machine 2, right? And you would be correct when you say that, right? You say run it on machine 1, run it on machine 2, it would be okay, and you would be correct. Let's get two physical machines and run the applications. They are isolated and they are not going to be incompatible in that situation, right? Application A is running somewhere else, they don't even know about each other's existence. But the thing is, think about it, if that is efficient or not. Not an efficient solution at all. Just to run another application that, of course, just to run another application, let's say B or A or anything else, you are just going for another machine, right? It's far too excessive, right? It's bringing a sword where you could have used a needle, right? So what would be another solution? Yeah, some of you may be thinking that, hey, why don't we do this thing? That, okay, we have the two applications, application A and application B. What we would do is, okay, we would run them on the same physical machine, okay? Now, 1 second. We'll run them on the same physical machine 1 or host 1, right? And on the physical machine, we are going to create two VMs, right? Let's create VM2 and let's create VM1. And we are going to run application A on VM1 and application B on VM2, and both of them would be running on the same machine. Would that solve the problem? Of course, yes. Like the previous example of physical machines, having two virtual machines would also solve that problem. But think about it now. Just to have this one single application run with this one, you had to have another virtual machine, right? Is this the most efficient solution? It's kind of, but it's not really the most efficient solution. It would work. But still, in order to run just this one app, you had to have another virtual machine, right? So compatibility wise, virtual machine would not be the greatest solution, right? Now we'll get into the concept of containers after this, but the thing is, these two solutions together are not the most efficient ones, right? And that's all we had about a decade earlier, right? About 10 years ago, that's all we had. Either have two different physical machines like in the early 2000s or in the late 90s, or have a couple of different virtual machines like in the mid 2000s and early 2010s. But we have a concept that's going to help us do that, right? That concept is, and of course you guessed it right here, that concept is called the containers, right? What do these containers do, right? These containers would actually be like on a single machine, a physical machine or a virtual machine, any machine could that be, right? We are going to have an operating system, and on the operating system we are going to create something known as a container, right? Let me write this one in a better way. Now, so let me write this down. On a single physical or on a single physical machine or a virtual machine, anything, right? It does not have to be a physical one, right? There would be an operating system. It could be Windows or Linux or any operating system of liking. Then there would be something called as let's call this a container engine, right? What you would do is that you would install a software, right? It's kind of like a software that you would install on the operating system, right? It's called a container engine, and it will let you create these isolated environments, right? It will let us create, this container engine would let us create these isolated environments. And what do we do with these isolated environments? We can put our applications 1, application 2, application 3 right here on this particular container engine. Now, the beauty of it is, and the most important thing about it is, that application 1 and application 2 would not even know of each other's existence. They would be completely isolated of one another, right? If the application 1 is running, application 2 would not know about it. And how does this happen? This container engine or this particular piece of software is actually created to keep them isolated, right? I'll get into how it keeps them isolated to some extent, but the thing is, to keep this very simple, right? To keep this very simple, what we would do is that we will have these physical machines. On the physical machine, I'll have the OS. If I did not have the container engine, let's assume that I did not have the container engine, then application 1 and application 2 would be accessing the same OS at the same time, right? And then the compatibility would have been an issue, that they are not compatible with each other. That's why they would give the errors, right? You can have multiple examples of this, right? These could be any two applications, right? Two different versions of the same application sometimes don't run on the same machine, right? Or sometimes you do not want to have an entire machine in order to run an extra application, right? So both of the cases would be true in this situation. Both would be a utility of containers, right? So why would I use containers now? First of all, for the isolation. Why isolation? Because I want application compatibility, right? I want applications to be compatible with each other. I want applications to be isolated with each other. And these things that we will discuss later would be, they are super scalable and they are super efficient. They're super efficient. Like these, and we will talk about all these terms, right? But for now, this is basically how you run the containers, right? Now, let's get into it for a second, right? You may have heard of these terms like a Docker, right? Actually, what happens is that on a physical machine, right, I want to run these two applications. I'm just repeating again. I want to run these two applications and I want to keep them isolated from one another, right? So what would I do is I will install a software on my operating system, right? Let's say this is Windows Server 2016. And oh, by the way, it does not, containerization or containers are not supported with Windows Server 2012, 2008 and stuff like that. It started with 2016, right? Or maybe some version of Red Hat, or maybe some open source operating system, like maybe you have Ubuntu and stuff like that. So the idea is that on this particular operating system, you will install a software, right? This software generally is called a container engine, right? And this container engine would either be Docker or some other. You can either create like Windows Server containers in case of Windows servers, right? But this would be the software that kind of would help you to create these containers. Now, you would be thinking that, what does Docker do exactly? Now, Docker lets you create, right? When you have heard of this term a lot of time, the Docker, it lets you create these isolated environments. It lets you create them, manage them, delete them, basically all you want to do, right? If you want to scale them up, basic deployments, this is going to help you with that, right? The Docker is going to help you with that, right? Now, since many of the people watching this video could be new to the concept of this containers, right? You can kind of compare it with virtualization as well. And by the way, on a lot of websites, when you read about this would be written: operating system virtualization. What the hell is operating system virtualization now? Thing is that they're using a single operating system in order to give isolated environments to multiple applications which would not have been possible, right? Now let's compare it with virtualization per se, right? This is solution number one, this is containerization. This solution would be virtualization. How do you do virtualization? Now, going back into the archives a little bit. In virtualization, the thing is, you have a physical machine, also called as the host machine, right? Host would have either Windows Server, or host will have any other operating system. It could have Red Hat, then you would use KVM something, right? On this physical host, usually there would be an operating system, right? This physical host, you would have an operating system with Windows Server or something like that. On the operating system, right? On the operating system, you would create some sort of an environment called as, now really important, you would have some environment called hypervisor. Now, what is this hypervisor? You're going to create virtual machines, right? You have to create these separate entities, these separate virtual machines, VM1, VM2, hold on, VM3, and so far, VM1, VM2, VM3. But in order to create these VMs, you have to have the software. This software called as hypervisor lets you create VMs like this, right? If you do not have this hypervisor, this would not have been possible. What does a hypervisor do? Hypervisor isolates things like RAM, things like storage, things like network, things like operating system for a particular VM, like VM1, VM2, VM3, right? For them, their RAM would be different, their operating system, their CPU, I should write CPU here as well. Everything will be given to a particular virtual machine for its own, right? VM1 would not even know that VM2 exists. VM2 would not even know that VM3 exists, so far, so forth. That's the idea, right? So that's what hypervisor lets you do. These hypervisors could be, examples of these hypervisors would be either by Microsoft, it could be Hyper-V, it could be VMware's ESXi, or it could be KVM, that is the open source one. So you have a lot of hypervisors as well, right? And there are different types of hypervisors as well. I'm not going to go into that. There's hardware virtualization, there's software virtualization, tier 1, tier 2, where the placement of the hypervisor on the operating system would change, right? I'm not talking about that. I'm just talking about the concept. The concept is that if hypervisor did not exist, does not really exist, you can't make virtual machines, right? That's the entire purpose of having a hypervisor, so that you can create these isolated environments, right? So that's what it is for, right? So the thing is, in the same way, if you do not have a container engine, then you cannot create containers. That's the entire purpose of the container engine, to isolate these things, like isolate the things like operating system, basically isolating a runtime for the application. Your application needs certain things from the operating system, certain files, or it could be certain things that it's dependent upon, certain functionalities that it's dependent upon to run itself, right? That's the job of the container, to do exactly this, right? Now, the thing is, some of you may be thinking that why do the applications, app 1 and app 2, if they are running on the same system? Forget about this for a while. If you would think that why are application 1 and application 2 not running in the, do not know that the other one exists. That's the simple idea. That's what the container engine here does, right? What it does is that when application 1 has some sort of a requirement that it needs to be fulfilled from, the operating systems or the physical machines end. Let's say application 1 has a certain file requirement or has a certain runtime requirement. It does not make the request right to the operating system, not really. It makes the request to the container engine. Makes sense, right? Application 2 in the similar way would make the request to the container engine as well, right? Now, the container engine would send the request to the operating system. For the operating system now, really important. For the operating system, where is the request coming from? Is it coming from the application or is it coming from the container engine? It's coming from the container engine. So this is a software that's running on the operating system. Operating system is going to assume that, hey, that's where the resource request is coming from, and it's going to relay that resource request to the physical machine. And again, that's how the requests are actually fulfilled, rather than application directly going to the operating system and demanding the same set of runtime, or maybe demanding the same set of dependencies that they have, right, and then clash there, container engine actually prevents them from clashing, right? Container engine prevents them from actually clashing and knowing that the other application even exists. So even the operating system, you could say to some extent, right? Now, this is, I would say that this is a simplification of what exactly happens, but this is a basics video. But you can say kind of, the operating system does not even know that there are different applications there, right? There are containerization aware operating systems, that I understand that, but for the sake of simplicity here, you can assume that operating system is treating this Docker, let's call this Docker now, and that's what I'm going to call it now, because container engine itself is a mouthful. So when the Docker makes a request, operating system is treating it as its own application, right? So then it's going to get the resources, right? Now, what's the advantage of doing this? First of all, we have solved the compatibility issue, right? Now the applications are compatible, not a problem at all. Other than this, it's an isolated environment. There is isolation because application 1 and application 2 would not, now really important statement, application 1 and application 2 would not communicate with each other by default. If you want them to communicate with each other, you can get them to communicate, but by default you would not get them to communicate, right? And other than this, each application right here, let me clear the board a little bit. So other than this, when you're talking about these applications, each application would have its own, you can say, part of operating system, right? Let's call it, for the lack of a better word, it has its part of the operating system. It has its own networking, it has its own storage, and it has its own RAM, right? Technically its own, you can say that it has its own runtime. Each application, right? This application has it, this application has it, so this, and this, and everyone has a different one of this, right? So the thing is, for this application to run, it never would need anything else, right? For this application to get to the network, it would never need anything else because it has its own network, it has its own storage, right? So technically what you have made is, you have made these small independent units within the system, right? Applications are inherently running on the same operating system, so that's why I would not really call them independent otherwise. But on the containers, you can call applications as like these independent packages that are not communicating with each other, that have their own operating system, that have their own, I'm saying that have their own operating system, but they have the part of the operating system, that have their own part of network, that have their own part of the storage, but you get the idea. And here, where the term sandboxing comes from, or maybe sandbox would come from, right? Each application has its own space to play, right? You have your own sandbox, they have their own sandbox, they have their own sandbox, they have different runtimes, they have isolated runtimes. So that is the basic idea, right? That's what makes this whole thing efficient, right? If you are comparing, let's say, the application here or the application running directly on a system, or maybe an application running on a virtual machine, right? The application that's running on the virtual machine, technically, the application that's running on the virtual machine would technically take longer to be deployed because the virtual machine would have to start, then the application would have to start. In here, if the system is already running, the startup speeds and the shutdown speeds and the startup speeds are way higher, so that is an efficient thing by itself, right? They are easy to deploy, they are easy to run, they are faster, they have a faster operation because again there are not a lot of dependencies, they are just a very simple situation, right? Other than this, what happens normally with the applications, they are usually running on the VMs, there is an operating system, that's where the application is running. That's a lot of dependencies. That's a really big chain, you would say, right, of things being dependent on one another, right? Now that's the three things have been discussed. What about the scalability? Now the thing is, Docker does not just make this possible for us to have the containers for these applications to be isolated into a kind of a box. Not just that. Docker actually lets you deploy plus scale the applications as well, right? If the application one has slightly more demand, or maybe there's more requirement for the RAM, there's more requirement for the network or the storage, Docker is going to give them, right? So you can always scale up using this, right? I can increase the RAM for the application, I can increase the networking for the operating system. I can increase the RAM given to a particular application, I can increase the storage given to an application, and I can increase the network bandwidth given to an application at any time. So it makes scaling very easy. I don't have to go into the hypervisor and extend or anything. It's not that complicated, right? It's very, very straightforward, right? And okay. Now that was like the absolute basics of this, right? Absolute basics of how this works, right? Now let's take this up a notch, right? Let's see how this actually happens in an environment, or how this happens inside of an organization of something, or something like practically how does this actually work. Now, the thing is, like I said, you could actually run this on a VM, or you could run this on a physical machine. It's totally up to you, right? So if you want to have another layer of isolation, that would mean if you want more security to some extent, if you want more security, then what should you do? Actually, what you should do is that get a physical host, right? Let's get a physical host, right? Let's run anything on this. On the physical host, there is a host OS, right? I'll just use a different pen for this. On the physical host, there is an operating system, right? The host operating system, right? On the host operating system, right? Let's assume that this is software virtualization for this example. In hardware virtualization, hypervisor would be a step down, right? But it's okay. Let's call this a hypervisor. It could be anything. On the hypervisor, now as you would know, there can be several different virtual machines, right? That's VM1, that's VM2, VM3, and so on, right? You can have multiple virtual machines. Now, these all virtual machines have different operating systems, right? So this virtual machine would have, let's say, Windows Server 2016, Windows Server 16. This VM has Red Hat something, Red Hat 7X, right? This has, again, Windows Server 2019, right? There are different applications. Now, first of all, you have created this, and now, and there are different examples. First of all, let me draw a solid line. It's this. Okay, let's see it. Now with this, on each of the operating systems, right? Let's say now you want to deploy the containers within the VM, right? You have created the VM environment, right? And there would be applications here. Let's say you create this VM and there is a Docker here. There's a Docker here. There's a Docker here. So different Dockers, right? Now, really, really important. And on each virtual machine, you are running application 1, application 2, app 3, again, you get the idea, 4, A5, A6, right? So imagine the level of isolation first of all here, right? What you're doing. First of all, this is a single physical machine. All of this is on one host, or on a single physical host, right? So there's only one box, there's only one server, and you're running so many applications totally isolated from one another, right? So that's what you're trying to do. So let's see. How many levels of isolation have you created in this one? How much secure this environment is now? Think about it. First of all, there is operating system level security. Yeah, we have that. There's hardware level security, because let's assume that we had something like BitLocker right here, right? BitLocker and TPM and other things like that, trusted platform module. But again, you don't have to focus too much on this in this environment, but there's security on the hardware end, right? Now, hypervisor make sure that where's the other pen? Yeah. Now, hypervisor makes sure that these VMs are isolated from one another. They are not speaking with each other. So technically, all of this is isolated from each other as well, right? So this level of isolation that's between the networks and the operating systems and the application. So there's one level of isolation, right? Another level of isolation is drawn right here by the Dockers, right? Now the Dockers are totally isolated from one another. They are on different machines altogether, right? And they have the applications running that are totally isolated from one another. So when you see this example, right, you should see technically two levels of isolation. Level 1 of isolation is right here. Level 2 of isolation is right here, right? So first level would be done by the hypervisor. It would break down the different virtual machines, and within the virtual machines, the second level would be done by the containerization engine or the Docker, right? So that actually adds to a lot of security, adds a lot to the security of these kinds of things as well, right? Now, you can create, now just to do a little recap, what operating systems can you do containerization on? Windows Server 2016 and above. A lot of open source operating system. Now Windows just introduced this concept of containerization around like 5 years ago, around that, actually 4 years ago. So when did the open source guys were doing it, right? If you ask any of your friends who works a lot on Linux and open source devices, this has been around for a decade or even more than a decade, almost a decade and a half now. This concept has been there. So Windows Server 2016, Red Hat, and a lot of other open source operating systems would support this. Docker is just a software. It's just a name of a containerization engine, just like Hyper-V is a name of a hypervisor, right? So that's what it's doing, right? It's container engine. So that's what it's doing. It's doing containerization. Hypervisors do virtualization, right? So now, in this containers, you can create multiple applications that are isolated from each other. It's called the operating system virtualization. What it does is it makes things isolated, compatible, scalable, and more efficient, right? How does it make it more isolated? Because again, there's different levels of isolation. Applications can't talk to each other. Compatibility, if they can't talk to each other, if they can't know of each other's existence, they would inherently be compatible with each other. What's there to be incompatible about if you're not together? Right, so that's compatibility. Scalability would mean that it can easily scale up, and by using, now coming back to scalability for a second, if you want to deploy these containers on the cloud, or if you want to deploy a bulks of these containers, let's say I want to deploy maybe 100 containers in less than 10 seconds or 15 seconds. I can use something called, as, and by the way, you might have heard of this, it's called Kubernetes, right? So you can use Kubernetes here as well, right? So that would make it more scalable, scale out in that situation. But Docker can make it scale up, increase the RAM, increase the network, or something like that if you want to do that. It's more efficient, startup times are faster, the speeds are better. Overall, since they are isolated environments, so they inherently become more what should I say? What's the term I'm looking for? So since they are isolated packages, they become more movable, right? You can carry them with you. They become more mobile in some extent, right? You can take it from one system to another. And by the way, there are different types of Dockers as well. Some would say that there are complete Dockers, isolated Dockers. You have then these Dockers that are tied to the kernel of the operating system. We'll discuss all of that when we move forward. But the idea is this. That's what it does for you, right? It's going to create a level of isolation that was not earlier given. And by the way, all of this example was just one physical machine. Just using this one single box or using a single laptop, you can have all the applications in isolation. Maybe if you were doing this 20 years ago or 15 years ago, you would have to have 1, 2, 3, 4, 5, 6 or 7 different physical systems to achieve this level of security and this level of isolation in the systems, right? So I hope this is helpful, and later on we will discuss Kubernetes services and how these containers can be moved to the cloud. And by the way, these containers, since I said they are mobile, they are easy to take from here and do a lift and shift on the cloud, do a lift and shift on Azure, AWS, GCP, all support containers. Technically, YouTube, where you're watching this video, is running on a container, right? YouTube is an application that's running on a lot of containers. That's what it does, right? So it is compatible with the cloud as well, right? So we will discuss all of that stuff. So I hope this was helpful. If there are any questions related to these containers or related to Kubernetes services or Azure or GCP or any cloud in general, any technological question, do write that down in the comments. Just let me know if you need any assistance with anything. Thanks for watching the video. Don't forget to subscribe to the channel if you haven't already. Thank you.